G'day guys, how's it going? So in this video, we're going to start talking about static variables in Rust, what they are, and how and when we should use them. So firstly, what are static variables? Well, essentially, they are variables that live for the lifetime of the program. So unlike other variables that we've seen so far, they pretty much live for the lifetime of a stack frame for when we call a particular function. With static variables, they live beyond stack frames and everything else. They must be able to be evaluated and initialized at compile time, and that's based on the fact that we want to initialize an initial value before the application even starts. We must define the type of the variable at all times. So for static variables, we must indicate if you want to store an integer, that you have to specify the type of integer, or if you want to store a boolean, you have to specify it's a boolean, and so on and so forth. And also, the result of using static variables is that we only have one instance of that variable, and that's because of the static nature in which it exists. It lives for the lifetime of the program, therefore, it'll only ever get created once, and as a result, will only ever get terminated or dropped once when the program terminates. They can be mutable and changed at runtime, but you must specify the mute keyword as you normally would with any other variable. But just keep in mind that in the Rust world, they kind of frown upon doing this. And in fact, what they'll do is force you to tell the code that you want to do it by specifying that the code is deemed unsafe. And we'll see an example of that in a minute. And then lastly, static variables do honor the idea of scopes like we've seen before with other variables. So just because that the variable lives for the lifetime of the program doesn't mean it is accessible in any part of your application. So where are static variables stored? Well, we know about the stack and we know about the heap, but there's another piece of memory that this program uses when it's talking about static variables, and that is the static memory. And that's at the bottom here. And essentially, with static variables, we store things in what's called a data segment. Now, I don't want to go into too much detail around how memory is kept for processes, but that's all you really need to know at a high level as to what happens. So, when the application starts, all of the static memory is loaded in, which includes these static variables and a few other bits and pieces, and then the program runs, to which the stack and the heap get involved. So that's it in terms of the knowledge. Now let's jump into the code and see how we can use static variables in practice. Okay, so we're in the code, and essentially all we need to do to set up static variables is to just type the word static, and usually you include them outside of functions like so. And then we can specify the name of the variable that we want. So say I want to have something called game code length, and I'm just making up this variable. And I want to set it to say 4, right? Now it's complaining at the moment because I haven't specified the type, so we must remember to do that. And now it's all okay. It's just saying it's unused, right? Also, I must specify initial value, like I said in the notes. Otherwise, it's going to complain, said it needs a static expression, right? So that's what that static expression is. It's essentially a value, right? So we can now come in and just use this in lots of places. So we can use it in our main function, like so. And what we can also do is create another function. Let's say print game length. And this can do exactly the same thing. And then that can also be called by the main down here. So this is kind of the idea you would have. You'd have multiple functions that require the same value to exist, right? And then you can create a third function and do the same thing. So you're sharing a global value that needs to be consistent across the entire application, right? So let's just quickly run and make sure this works. And yeah, we see that 4 is printed out twice because we're printing it out here. And then we're calling a function, which is also printing out the same value. Cool. So that is a very simple example of a static variable in Rust. Now, this is immutable because we've chosen not to specify mute there, but we can do that. So let's see how that works. So we'll go static, mute, and I'll just say total number of players, and I'll set that as a U8 as well. And by default, we'll say 10, right? And then we'll kind of just print this out as well, or at least we'll try to, and you'll understand what I mean in a minute. So we'll try and print this out, and oh, what is this? Well, we actually get told that we're trying to read a static value or a static variable that is mutable. Now, as I said, Rust flags this as something they don't want you to really do, right? And the reason for that is there are other ways of getting around having global values in this nature and having them writable, and that is to use other patterns that are out there. I don't want to talk about them right now, but essentially, setting up a state mutable variable is not something that Rust wants you to do. So that's why it gives you this warning that things are unsafe. And that's because with static variables, they can be manipulated in multiple threads, which again, we haven't spoken about threading yet. So we'll get to that a little bit later. But to get around this for the moment, we have to use an unsafe block like so, right? So this code needs to go inside of the unsafe block. And then once we do that, now it'll accept it and we can run it and we can print out the value. We can also change the value inside the unsafe block. So say I now want it to be 11 instead of 10. Well, we can do that and it's okay, right? It spits out 11. And obviously, if we try to write it outside the unsafe block, it's going to give us the same error. Yeah, it's going to tell us that this is unsafe and it needs to be in an unsafe block. Cool. So that is a really simple example of creating a global static variable and a mutable one. Now, what you can also do is use other types, but the types have to be constant. And what that means is they must be able to be calculated at compile time. So I'll show you some examples of ones that can be calculated at compile time, which you've probably seen a lot of these before. They will be mostly value types, right? So say we have something called numbers. We could make an array of, say, 5 numbers, and this is okay. We can do this. We can go 1, 2, 44, 5, and 7, right? And this will compile just fine because this is a static list that can be, well, it's constant, right? It's going to remain the same. So as a result of that, now I can come down and we can print this out as well, right? In fact, we need to use this approach. It's an array. And if we run this, everything's going to work fine. You can see it gets printed out as well. So we can share numbers all over the place, right? We can do the same thing down here, in here. And now we're sharing an array around, right, at a global level. Cool. So obviously we can do tuples as well. So if I go static, and then we say something like player default tuple, and we define it as a tuple where the first value is, say, a string slice, and the second one is, say, an I32, right? We can then create a default value here of, I don't know, username, spell it right, and 0. And this will be also considered an acceptable static value. And just again, we can print that out just to prove that it works. So if we run, you can see the tuple is available here at the bottom as well. Cool. Now, what doesn't work is something like this, right? If I go static, let's say game code prefix, and I'm just making up all these variables. That's not the important thing, right? If I say I want to store a string inside that static variable, and I try to do something like this from, let's say, test, this is not going to work. And the reason why it's not going to work is this function is not a constant function, right? And we'll get into a future video about what constant functions are. But this is essentially a function that doesn't allow us to execute it at compile time. It has to be executed at runtime. But static variables must be defined and initialized at compile time. So this is not going to work. What we could do though is if we wanted a string, we can use string slices because they can be defined as literals, right? So we can do something like this, and now we have our static variable that can be accessed, right? So now I can do the same down here as I did with the rest, and I can print out that piece of text. And there it is there. Cool. Now, just to be complete, we'll show quickly that a static variable can also be scoped to a function. So say I have a static variable defined in my main, and I'll just call it local static variable, and I'll set it as, let's say, an I32, and I'll equal it to 100, right? Because I'm in the main function at the moment, I can print it out inside of main just fine, right? It's kind of treated like a local variable here, right? The only difference is this will live for the lifetime of the program, right? This will not get dropped when main stops executing. Same as if I was to do, say, something here where I go local game length variable. This will live for the life of the application as well, this variable, but it will only be accessible to this function, right? And nothing inside of it. And I'll show you in a minute how we can prove that. So let's say instead of putting it inside of main directly, we put it inside of a block, right? Just by doing this, I'm going to get a compiler error. That compiler error is based on the fact that this static variable is in a block scope, and therefore it can't be used outside of that block. And that is why this is complaining, right? Same as if I go back to what we had, and I try to access this up here in another function. Because of scoping, this too will also crash, right? And there it is right there. It's not in scope, right? So static variables do honor scoping, but generally, if you're going to use static variables, you're going to define them globally like here at the top, and you're going to utilize them wherever you need to in your program. Cool. And that's where I'll end this video. So the next video, we'll look at the other major constant that's out there that we will use a lot in Rust, and that is the const variable. So I'll see you all in the next video.